It's going to be roots and zeros. So first, let's just go over what you already know. Remember, a zero of a function f(x) is where f of that number gives you y of 0. That's why it's called a 0. And then when it's graphed, the real zeros are also the x-intercepts. So here's an example picture. If c is a 0, then c is also called a root. If you change the sign, you get a factor. And if c is a real number, then that's called an x-intercept. So for the problem below, there are 4 zeros. There are also 4 roots. There are 4 factors if you change all the signs. And of course, there are 4 intercepts. X-intercepts, right? So you know those are all the same thing. There's a picture. You can see 1, 2, 3, 4 roots, zeros, x-intercepts. Right, so when solving a polynomial equation with degree greater than 0, there may be 1 or more real roots or no real roots, meaning they're imaginary. And since real numbers and imaginary numbers together make our complex number system, we can say all polynomial equations with degree greater than 0 have at least one root in that set of complex numbers. That's called the fundamental theorem of algebra. All right, so if there's a degree greater than 0, it has at least an answer. It could be real, it could be imaginary. All right, so here's example 1. Solve each equation. Tell me the number of roots. Well, there's their problem. You could do factoring or you could do quadratic formula. If you do quadratic formula, you know you get a discriminant of 0. It's going to be the same answer twice. It's -3 comma 0, -3 comma 0. It's twice the factor, so that's why we call it a double root. Or you could say a repeated root. But if there's 2 roots, that means there's 2 solutions. All right, and there's the graph. You can see it touches once, but it touches there twice, so it's 2 solutions. This next one, B, x cubed plus 25x equals 0. Remember, always factor. Take out an x, leaves you x times x squared plus 25. If you do the 0 product property, you say each factor equals 0. Well, x equals 0, that's one root. When you do x squared plus 25 equals 0, you could do quadratic formula. You get 2 imaginary roots, positive 5i, negative 5i. Right, you could check the graph, you only see 1 real root. But again, we did quadratic formula, you got 2 imaginary, so there's 3 roots total. So following that, notice the amount of solutions in example 1 match the degree. Right? This had a degree of 3, there are 3 roots. This had a degree of 2, there are 2 roots. That comes from what we call the corollary of the fundamental theorem of algebra. So whatever the degree is, that's how many roots there are. So 3rd degree, 3 roots. 4th degree, 4th roots. 5th degree, 5 roots. Nth degree has n roots. Right? So that's how many solutions there are. And imaginary roots always come in pairs. There's an even number of them. All right, next. French mathematician René Descartes discovered a relationship between the signs of the coefficients of a polynomial function and the number of positive and negative real zeros. So there's a trick he found called the rule of signs. Basically, it says the number of positive real zeros of p of x is the same as the number of sign changes less than by an even number. Not sure what that means second. The negative is the same idea, but instead of p of x, you do negative p of negative x, meaning change the sign for anything that has an odd degree, and less than that by even number. So here's my example. Set the possible number of positive real zeros, negative real zeros, and imaginary zeros for that. Well, you see the degree is 6, so there's 6 roots. Some might be real, some might be imaginary, and some might be negative. So first, keep it exactly the same. I'm checking to see how many positive real roots there are. This is long. All right, to find out the number of real roots, just figure out how many times the sign change. So it starts positive, positive, negative. So right here, it changed. I'll put a C for change. Then it's negative, negative, positive. Right here, it changed from negative to positive. It's a change. And then it goes from positive to negative. There's a change. And then from negative to positive, there's another change. There are 4 changes. So that means there are 4 positive real roots, or anything less than by even number. So it would be 4, 2, or 0. Alright, so 4, 2, or 0 real, I'll say positive real. Alright, now notice I did not say 6, so they all can't be positive. Next, we are going to try f of negative x. So basically plug a negative x in, that changes all the signs of everything with the odd degree. So this is x to the 5th, that means I change signs. X to the 4th is even. X cubed means change signs. X squared stays the same. X means change signs. That's not. So one more time. We went from positive to negative, so there's a change. Negative to negative, negative to positive. Here's a change. Positive, 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 positive. That's it. There's only 2. So 2 or any even number less than that, or 0. Negative real roots. Alright, and then the rest will be imaginary. So now we make a chart of all possibilities. Alright, so remember it has to be 6 total. So it could be 4 positive, 2 negative, and 0 imaginary. Or maybe 4 positive, 0 negative, 2 imaginary. Maybe 2, 2, 2, or 2, 0, 4, or 0, 2, 4, or 0, 0, 6. Maybe all 6 are imaginary. Alright, all we know is it's one of those possibilities, but we don't know which one. So that's the sad part. So this gives us some idea, but not too helpful. Alright, so let's see how they used it. For example 3, use synthetic division to find all the zeros. So first, determine number of zeros. They said the degree is 4. Degree 4, 4 zeros. They did that sign change what we just did. They noticed it could be 2 sign changes for positive, 2 sign changes for negative. So it's either 2 or 0 positive, 2 or 0 negative, and then the rest could be imaginary. So maybe 2 positive, 0 negative, 2 imaginary, or 2 positive, 0 negative, 2 imaginary, or maybe 0 positive, 2 negative, 2 imaginary, or maybe 0 positive, 0 negative, 4 imaginary. So those are our cases. They wrote that, and they just tried some numbers to try negative 3, negative 2, negative 1, 0, 1, 2. They plugged it in synthetic substitution or division to see which one had a remainder 0. Now this is just really guess and check. There's no good way to try. And I don't like doing this blindly, but at least some method is better than no method at all. So they got negative 2 as 1. Well, remember, it was either 2 or 0 negatives. If they got 1 negative, that means there's 1 more negative. So they tried the other numbers. Remember, don't do any repeats. So they tried negative 4, negative 5, negative 6. Well, negative 4 worked. So when they did that, they got depressed polynomials. They ended with 1x squared minus 6x plus 10. So that is quadratic. You can always do quadratic formula, which is exactly what they did. They got 2 imaginary answers. Alright, so there was 2 negative, 2 imaginary in this case. So 4 zeros, negative 4, negative 2, 3 plus I, 3 minus I. Alright, it's best if you just check with the graph, but you can see here, there are 2 negative roots. One right there, and one right there. Alright, so I would just use a calculator to see the real zeros, count them, and then whatever you don't see is imaginary. Alright, in chapter 4, when we're doing the complex stuff, imaginary stuff, remember if you had one root, 4 plus 6i, then you had another root, 4 minus 6i. We call those conjugates. So this works for polynomials as well. So basically remember, imaginary roots always come in conjugate pairs. What if you have a plus bi, then you have a minus bi. The term that goes with the I changes signs. So if you have 0 plus I, then it comes a partner, 0 minus I. Or maybe a different one, if you have 3 plus 4i, it comes with a partner, 3 minus 4i. Because if we multiply them, you get rid of the i's. So they're the conjugates. So, like this at the bottom, when you're given all the zeros, and you have to find the equation, convert them to factors by changing the sign next to x, and then multiply them all together. You probably have to FOIL or distribute a lot. So here's an example. Find the polynomial function at least degree with intercoefficients if the zeros are 5 and negative 2i. Well, so my zeros or roots are 5, negative 2i. Remember, negatives come, magic come in pairs, so I have to change the sign. Positive 2i. So y'all have done this already. I'm going to do the first one, x minus 5. X plus 2i because I changed the sign, and x minus 2i because I changed the sign. Alright, well, we're going to multiply that. Your choice how you want to do it. I'm going to do the right two first because the imaginaries are nice. So I do x times x, I get x squared. X times negative 2i is negative 2ix. This times this is positive 2ix. This times this is negative 4i squared. Well, these combine till they're gone. And don't forget that I squared is negative 1. So negative 4 times negative 1 is positive 4. Alright, so here's where I am now. And then I'm going to FOIL again. So x times x is x. Or x times x squared is x cubed. X times 4 is 4x. Negative 5 times x squared is negative 5x squared. Negative 5 times positive 4 is negative 20. Now they usually like you to put the answer in order, and I'll use f of x instead of y. So f of x equals x cubed minus 5x squared plus 4x minus 20. Right. That's the least degree function, integer coefficients with 3 roots, 5, negative 2i, positive 2i. Alright, here's your practice problem. Try it. Find the number of roots. Should be really easy. The answer is 7. Again, if you can do that, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you in class.